All right, everyone. Today we're here to talk about experimental probability, and we're going to consider this simulation where a driver gets in his car every morning and drives to an intersection with a traffic light. At the light, we know the light is either red or it is green. We're going to ignore the yellow. So the light is either red or green. The first day, the light is red. So let's start to simulate this scenario. So I have my table here. First day, the light is red, so I'm going to give red a value of 1, and so I have a total of 1 reds, and so cumulative percentage, it's 100%. As I go to day 2, let's now go over to our document here and see what happens. So here's the same table, day 1, and I'm going to do lots of days, and I have red, and I'm going to go and look at what was previously done. And so the next time I come along, it is a green light. So the value is 0. The cumulative is 1 because it's 0 plus 1. And I have 2 days, and in total I've done 1 red, so it's 50%. And this graph here starts to show, here's day 1, here's day 2, it's 100%, down to 50%. And if I take this now, and I'm going to drag it down just one more day for the third day. The third day, it is again green. So value of 0. The cumulative reds I just have 1 red. This total here is 1 red. And so my percentage, I have 1 red divided by 3 days, 33%. And so you see it goes down to 33. And so on. I'm going to drag the next day. And this time it's a red light. So my value is 1. The cumulative, I have 2 reds in total. And so of 4 days, I have 2 red lights, it's 50%. And now I'm back up to 50%. And I'm going to keep on dragging this down. And there is my 6 days that I can have for my total. I can see that it's the cumulative total at 6 days is 3, and so it's 50%. And that is what my table here can show. And as I move back and forth, I can see this graph goes up and down as it continues. Now, if I go and can look at the whole scenario, if I drag it down to 100, let's see what happens then. If I take this and drag it down for 100 days, it's going to do the computations for 100 days, or 101 days. And so the final day, it was green, so it was counted as 0. There were in total 28 red lights, and so the proportion is 28. So we can see what the last 2 values were. If I go now and look at my table, I can see it started off at the probability, and this is cumulative reds, the probabilities, and then it started to kind of plateau over here. Right around here. So from this plateau, I can estimate that the total probability, or not total, the probability of hitting a red light, my best estimate is 28% for me to hit a red light. So that's the idea of experimental probability. I know the probability then of hitting probability of a red light is approximately 0.28%. Because if I look at the long run behavior of all those probabilities, that's how often I hit the red light. And so let's look at some of these definitions that we use in probability. The first one is trial. And if we consider our example with the car, a trial's definition is a one run of a particular experiment, procedure, or observation. And in this particular case, with the car and the red light, that's going to be driving up to the light. It's not if the light's green or red, it's just the actual act of going to the light is our one trial. And then at the light, we have possible outcomes. Our outcomes is the result of a single trial. In this case, we could either have the light be red or the light be green. And that leads us finally to an event. The event is what actually happened. we're looking for a group of one or more possible outcomes in the trial, what we're looking for. And we're looking for, in this case, the light to be red for this, in this particular example. For simple ones, there's just event is usually one outcome, but it could be a possible group of different outcomes. And so probability, as we just seen, is the long-run relative frequency of the event. So after many trials, what is the percentage that the event the percent that the event successfully occurs? So if you look at this graph again, we look at this graph, in the long run, where does this graph going to plateau? What percentage? And that is the probability. That's a definition of probability, the relative frequency. So another way to think of it is the total number of successful outcomes divided by the total number of trials. And if we think about this scenario here, our total outcomes, we had 100 days. This was 100 on the bottom, and 28 was on top. This was our top value. Okay, so there is a simulation to show us long-run probabilities of the red light, green light, traffic light scenario. So a couple of examples. If we have 10,000 doctors who took aspirin every night for 6 years, and 104 of them had heart attacks, what represents a trial in this case? Well, a trial is simply one doctor who takes aspirin every night for 6 years. We look at each doctor, that is a trial. He represents the trial. What represents the outcome of each trial? Well, the outcome is whether or not the doctor had a heart attack. And finally, a new doctor is selected at random who has been taking aspirin every night for 6 years. What is the probability that this doctor will have a heart attack? Well, the probability of a heart attack, so P, heart attack, and this is an introduction to probability notation. So probability of the event happening is going to be 104 divided by 10,000, which works out to 0.0104, which is 1.04%. And so that's the probability of this doctor having a heart attack. And what is the event? The event is having a heart attack. Here's another example. Bob rolls a regular 6-sided die. Here's our die. What represents a trial? Well, a trial is simply rolling the die, the act of executing this experiment of rolling the die. What represents the outcomes of this particular scenario? Well, it's a 1, 2, 3, 4, 5, or 6 are the outcomes. Now, what is the probability of a 1 or an odd number? Well, a 1 or an odd number, well, I could have a 1, a 3, or a 5. So the probability of a 1 or an odd number, odd, is equal to 3 out of 6, which is 1/2. And what is the event in this case? The event is simply a 1 or an odd number.